Let's now work through an example. As always, I would encourage you to try to work it or at least set up the problem by yourself and then come back and watch the video for the solution. So in this example, we want to find the equivalent transfer function for the system shown below. So our equivalent transfer function, of course, T of S is going to be our output C of S divided by our input R of S. And so of course we see we have multiple subsystems represented by our individual blocks throughout the system. We have some of these paths going forward. We have some paths coming back, so we know we're going to have to incorporate feedback at some point. And so as you can imagine, if we were trying to just look at this and without reducing it, say what type of response we're going to have, that would be very difficult. So sort of our game plan here is we want to try to identify areas where we can use those three basic forms. So for example, we can see here in the middle, we have our two S blocks, which are connected in cascade. So because we have these two things in cascade, we know that those are going to combine to be S squared. We have S times S because for cascade, remember our GEQ is the product of our blocks in cascade. Sort of doing two steps in one so that we're not redrawing this frequently every time, we can also see that that cascade combination of our two S's is going to be in parallel with this 1 over S block below. So we can say that these items here are going to be in parallel. The reason that we can say those are in parallel, again, we want to say, do they have the same start point? Yes. And do they have the same end point? In this case, also yes, because both of them end in that summing junction. Okay, and that parallel combination, remember for things in parallel, we just add or subtract. In this case, both things are being added into that summing junction. So our overall parallel combination, we're going to have the S squared, which we got from the cascade, plus the 1 over S from that parallel branch below it. So now what we want to do is redraw our system with those simplifications. So let me just resize that. So what we can do is we can say we've reduced that sort of internal piece with those three blocks to just an S squared plus 1 over S. So all of that in the red circle has been reduced to this. So now it's just a matter of filling in our system as it was outside of that. So we're still going to have a summing junction to the left. We're still going to have this 1 over S block over here. And our output here, C of S, which is being fed back through this other S block here. So that's coming back here. We have our initial input, R of S. And we have as well a connection here. And so this is being subtracted, added, and subtracted. And so what we can see here is as we said before, we're definitely going to have some feedback coming in at some point. However, we look at this summing junction and we notice that we have two items coming back. And so we don't know how to deal with that with our basic feedback form. We only had one item coming back. So what we want to be thinking about doing is, well, here's two things that sort of have the same end point, but unfortunately they don't have the same start point. So they're not quite in parallel. However, we talked about a way that we can adjust this block diagram to get those items in parallel. The way that we're going to do that is we want to be able to move this block to the left of the pickoff point. So we want to move this here. So move left of our pickoff point. And what that's going to allow us to do is then simplify our parallel combination and ultimately do a feedback form. So let's go ahead and move that block across our pickoff point. So as we were sort of, our main goal was to get this S squared plus 1 over S. And now we're going to have that 1 over S block here on this side of our pickoff point. But as we saw in a previous video, we're also going to have to adjust this upper path, because remember this upper path here was not multiplied by 1 over S, but now all of a sudden it is going to be multiplied by 1 over S. So we have to compensate by putting a block here with a value of S. And so again, if we sort of go through here, we say it's now 1 over S times S, so we get back to whatever it initially was. The two blocks cancel out, which is the same thing we had here, just whatever it initially was coming out of that S squared plus 1 over S block. Okay, and that's going to be coming back into this summing junction. So we get that coming in here. We also have our S block down here. So we have our S block here, which is also coming into that summing junction. So those were both being subtracted, and then our initial input, R of S, is being added to that summing junction. Okay, so now we can make a couple more simplifications. Again, we see in the middle we have this simple cascade form. So remember, for cascade forms, what we're going to do is just take the product of those two. And then also on the sort of outside, we have these two S blocks, which are going to be in parallel. Again, we always want to check for parallel. They both have the same starting point on the right, and they both have the same ending point on the left. So that means we're good to go with using our parallel form. Okay, so let's reduce that once more. And what we're going to get is we have one block sort of in the middle there. So that was the S squared plus 1 over S. And we said that was in cascade with 1 over S. We're going to multiply those two like that. And now we had S and S both in parallel because they were both being subtracted here. So they were both being subtracted. We can just say that we are going to have both of them still being subtracted. So we were subtracting 2S, one from the top, one from the bottom. Now we're just subtracting 2S from the bottom. Okay, and so once I finish drawing this, what we're going to see is we have our basic feedback form. So we have our input coming in here, R of S. All right, so now we have our feedback form. Important to note, so I've left off the plus, important to note that we have negative feedback. So that means in our equation, we're going to need to use the positive sign, or we're going to need to add in the denominator. We can also, if it's helpful, go ahead and label this is our G of S up here. So our S squared plus 1 over S times 1 over S. And down here, our 2S is our H of S. So now what we're doing is we're just plugging into our equation for our feedback form. All right, and so ultimately what that's going to give us then, remember, is our GEQ. So we're going to have some GEQ, some single transfer function, which is going to be G. So our G is S squared plus 1 over S times 1 over S divided by 1. And remember, we want to use plus because we had negative feedback here. So plus G times H. So G is S squared plus 1 over S times 1 over S, and then our H is just 2S. All right, and so that's our single block. So we have R of S times that gives us C of S. So now all that's left to do is just simplify that with a little bit of algebra. So we can say our T of S, our overall transfer function that we were looking for, is C of S divided by R of S, which is equal to, and now just to show a couple steps, so we can have our S cubed, we can simplify the numerator to S cubed plus 1 over S squared, so just finding a common denominator after multiplying through. And similar thing in the denominator, we get 1 plus 2S cubed plus 2 divided by S. And with a few other steps, again, if you have any questions about what those are, we can reduce this to the quotient of two polynomials. In the numerator, we have S cubed plus 1. And in the denominator, we have 2S to the power of 4th plus S squared plus 2S. And again, we didn't necessarily look explicitly at fourth order equations in our previous notes, but we could still figure out, just because we haven't done it doesn't mean it can't be done. So we could figure out what type of response type to expect for our system based on this. And that's a lot easier to characterize than looking at our initial mess that we saw here. So this was, I would say, a moderately difficult example. So if you want an easier example to get some practice, you can look at example 5.1 on page 242. And so that's actually the 7th edition of our textbook. I'll provide an 8th edition page number if anybody's interested. And if you're looking for a harder example, you can see example 5.2, which is on page 243, also of the 7th edition textbook. And what we're going to do in class is we're actually going to come back and we're going to see several ways that we can use MATLAB to do this reduction sort of a lot easier, so we're not having to go through all these steps. However, with 2 of the 3 methods that we're going to look at, you are still going to need to be able to recognize when we have a cascade, parallel, and feedback forms present.